Antony Raj from Vetrii NEET Gateway. Okay. We already discussed about atoms in the previous videos. So today we will discuss about molecules. Okay. From 9th standard chemistry. What is a molecule? A molecule is an independent entity which has the properties of a particular substance. Okay. A substance is made up of molecules. Okay. So the molecule is the independent entity which shows the properties of the particular substance, right? Okay, when I say molecules, the atoms they combine to form these molecules. So if there is a single atom, we call it atom. When the atoms combine, okay, we get molecules. Okay, the molecules can be elemental or which can be a compound. Okay, for example, if you take noble gases, so they are only single atom. Okay, they are single atom molecules only. For example, helium, neon, argon. Okay, so these are noble gases. Okay, they'll have only single atoms in their molecules. Okay, then if you take O2, there are two atoms, and oxygen, dioxygen. If you have O3, which is ozone, there will be three atoms. If you take N2, two atoms, and phosphorus will contain four atoms in their structure, and sulfur will have 8 atoms. So the sulfur molecule section only, okay, it's given here, right? Okay. So these are elemental because they have only one type of atom. Okay. So oxygen, nitrogen, phosphorus, sulfur. If they have only one type of atom, then they are called elemental. Okay. So when they have more than one type of atom, then they are called compounds. You are given some examples here: H2O, NH3, CO2. Okay, there are so many examples. Okay, so we can say NO2, right? So these are all having more than one type of atoms. Okay, right? So they are called compounds, right? So now we must know what is atomicity. Atomicity is the number of atoms present in a particular molecule. That is called atomicity, right? So in O2 there are two atoms, atomicity is 2, O3 atomicity 3, N2 2, and P4 4, S8 8, okay, which is called atomicity. Okay, so in H2O there are three atoms, 2 hydrogens, 1 oxygen, NH3 1 nitrogen, 3 hydrogens, carbon dioxide 1 carbon, and 2 oxygen. That is called atomicity. Okay, number of atoms present in a particular molecule, right? Okay. Next we must know what are ions. Okay, so what is the difference between an atom and ion? An atom is a neutral particle, whereas an ion is a charged particle. Okay, so as we know, right, the charged particle can have either a positive charge or a negative charge. Okay, they are charged particles. They are called ions, right? The ions can be monoatomic and polyatomic. I'll give you some examples. Okay, monoatomic ions. Say H plus is monoatomic. Okay. Na plus monoatomic ion. They are positively charged, right? Then we have K plus monoatomic. You have Cu plus monoatomic. Okay, if there is only one atom and has a charge, they are called monoatomic. Likewise, so these are all called cations, positively charged ions. We also have anions like O2 minus, okay, then Cl minus, right, then F minus, Br minus. So these are all negatively charged monoatomic ions. They are called anions, right? So during electrolysis, okay, the positive ion will go towards cathode. They are called cations. The negative ions will move towards anode. So they are called anions. Okay, so the examples I have given is monoatomic cations and monoatomic anions, right? Okay, similarly we have polyatomic cations and anions. Polyatomic, we have NH4 plus ammonium, which is a polyatomic cation, right? Polyatomic anions, we have carbonate, CO3 2 minus, okay, HCO3 minus, bicarbonate, Okay, sulfide, SO3, 2 minus, then sulfate, SO4, 2 minus, etc. Okay, these are all polyatomic anions. Okay, negatively charged polyatomic. You can easily understand polyatomic means there are more than one atom in that ion. Okay, so cation polyatomic means more than one atom in a positive ion. Right? So polyatomic cations and polyatomic anions. Right? Okay. So now you must understand what is ionic compound. Okay, there is something called covalent compounds. So about covalent compounds, what is covalent bonding? Right? Okay, how the covalent bonds are formed. Okay, that we will study in detail in higher classes. Right? So there are different ways of the atoms combining together to give molecules. Okay, one way is ionic, the other one is covalent. Okay, so that we will study in the higher classes. Okay, for now, we will take some ionic compounds, which is calcium oxide, which has calcium 2 plus cation and O2 minus anion. So you must understand that, okay, the molecules are neutral as such. Okay, they don't have any charge. If they have a charge, then we call them as ion. Right? Right. So O2 minus. If you take NaCl, which has Na plus and Cl minus, if you take magnesium sulfide, then you have which is Mg2 plus and S2 minus. Okay, these are some of the ionic compounds. Right? So if you have to give some polyatomic compounds, let's say which is Na2CO3, which will have Na plus ions and CO3 2 minus ions. Right? If you say take copper sulfate, CuSO4, okay, Cu2 plus, then SO4, 2 minus, right? Right. So like that, we can give many examples. Say aluminum phosphate, okay, or aluminum sulfate, Al2SO4 thrice. Okay, I will explain to you. So why we have this 2 and 3? Okay, as the molecule has been neutral, therefore the positive charge will be equal to the negative charge. Okay, we will discuss about valency in a short while. Okay, then we have calcium phosphate, Ca3PO4 thrice. So these are some of the examples of polyatomic molecules. Okay. So to understand the combination of atoms to give molecules, you must understand an important term called valency or this combining capacity. Okay. So how the atoms combine together to form a molecule. So valency, okay, I can define as the number of electrons in the last orbit, right? Or here you can say the charge on the cation and the anion, right? Okay. Valency is the combining capacity, right? Now the valencies or the charges on the ions must balance so that the molecule is neutral. Okay, if you take the example of calcium oxide, we have calcium 2 plus ion is there, so O2 minus, right? So calcium 2 plus O2 minus. So now if you see there is plus 2 charge on calcium and minus 2 charge on oxygen, we get calcium oxide. Generally when we write molecules, okay, the positive ion symbol is written first, calcium 2 plus is written first, then negative ion is written second. So cation first and then anion second, right? That will write the chemical formula, right? If you take FeS, again it is Fe2 plus, then S2 minus, ferrous sulfide, right? Okay. Then which is cupric oxide, sorry, which is Cu2 plus O2 minus, right? Okay, if you take MgOH twice, then we have Mg2 plus, a monoatomic positive ion, and then OH minus, which is a polyatomic anion, right? So why the bracket is there? The bracket is there for both O and H. Okay, we cannot write like this. You cannot write MgOH 2, you cannot write. Okay, you have to place a bracket so that it is OH twice. Hydroxide ion, which is a polyatomic anion, right? Right. So now again if you see, we have to balance the charges. Mg2 plus, OH only a single minus. So if you have to balance the charges, then MgOH twice. Now Mg2 plus and 2 OH minus, therefore minus 2. The charges balance. Whenever you write the chemical formula, okay, the molecule is as such is neutral. So the positive charge and negative charge have to balance. Then calcium carbonate again, which is calcium 2 plus and CO3 2 minus. Okay, it's a polyatomic anion which has minus 2 charge. Then if you take ammonium sulfate, we have NH4 plus, which is the cation. Here only 1 plus is there, but SO4 is 2 minus. Okay, therefore it has to be NH4 twice SO4. Therefore NH4 twice SO4 then becomes plus 2. For one NH4 1 plus, NH4 twice plus 2. Then SO4 2 minus. So the charges balance. Okay, so when you write ionic compounds, right, the charges has to balance. The charges have to balance. Okay, the positive charge becomes equal to negative charge. The positive charge of the cations equals the negative charge of the anion, so that the molecule is neutral. So always have that in mind, okay, when you write the chemical formula for molecules. Okay, here I want to give you some examples. Okay, so when you get used to that, you will remember them easily. I'll give some examples of, okay, positively charged cations and negatively charged anion. Okay, right? I've already given you some examples like Na plus, K plus, Cu2 plus, and here you must also know about the variable valencies, okay, of the metal cations, right? Okay, so copper 2 plus, and there is one more which is copper plus. Okay, that's a variable valency. Then you have Mg2 plus. Similarly, we have Fe2 plus. Okay, then Fe3 plus is also there, variable valencies. Fe have two different valencies. One is plus 2, another one is plus 3. Right? Okay, then we have zinc 2 plus, okay, and so on. Like that, if you come to anion also, okay, I will give you some examples. Cl minus, Br minus, I minus, O2 minus, okay, N3 minus, right? So these are some of the examples of, we have something called magnesium nitride, which will be Mg3N2, okay. So 3 into 2 plus 6, okay, 3 into 2 plus 2 Mg2 plus, and higher than 2 into minus 3, minus 6, okay, magnesium nitride, right? Okay, N3 plus, then halogens have single minus, okay, these are some of the examples of the cations and anions, right? Okay. In polyatomic ions also, I want to give you some examples, some more examples. HCO3 minus, okay, CO3 2 minus, SO3 2 minus, sulfite ion, SO4 2 minus, sulfate ion, PO4 3 minus, phosphate ion, okay, and so on. Okay, you will get used to this. Then we already seen OH minus, okay, hydroxide ion, okay. Then coming to polyatomic cation NH4 plus. So these are some of the examples for the polyatomic cations and anions, right? Okay. Now how to write the chemical formula, right? So how to write the chemical formula for different substances. Okay, that you must understand. Listen carefully. Okay, we'll take one example. First we'll see simple binary compounds. Okay. In binary compounds, only two ions are involved. Okay, only two elements are involved. For example, the simple example is NaCl. Okay, Na plus Cl minus. Okay. Suppose you want to write Na2O. Why it is Na2O? So here you have to consider the valency. Okay. So NaO. Okay, for sodium the valency is plus 1. For oxygen is minus 2. Okay, now you cross these two numbers. So Na2 and O. Okay, Na2O. Similarly, another binary compound will be calcium chloride, CaCl2. Okay, how do you get CaCl2? Calcium 2 plus and Cl single minus, okay, minus 1, cross this, we get Ca1Cl2, that is CaCl2, right, that is CaCl2. Then magnesium, okay, so these are all some of the binary compounds where only two elements are involved, okay. Now we will take some examples of, okay, non-binary compounds, right. So take for example calcium, aluminum sulfate. So aluminium SO4 sulfate. The two ions, for aluminium it is plus 3, sulfate minus 2. Okay, cross this, you will get Al2 SO4 thrice. Okay, so if you cross multiply, the valencies will clearly balance. Okay, then you have calcium phosphate. Okay, calcium phosphate CaPO4. PO4 3 minus, calcium 2 plus. So it will become Ca3, cross this. Okay, Ca3 PO4 twice. So like that, you can easily write the chemical formula. Okay, so what is the formula for that ion? Okay, then write the valencies. Okay, cross the valencies, you will get the chemical formula of the compounds, right? Okay, if you will take few more examples. Okay, one is aluminium oxide, AlO. So aluminium plus 3, okay, minus 2, you will get Al2O3, which is alumina or aluminium oxide. Okay, so consider sodium nitrate, sodium Na, and for NO3 1 minus only. So plus 1, so if you cross, you will get NaNO3, sodium nitrate, right? So like this, you can write the chemical formula, right? So if you want to take, say, calcium bicarbonate. So calcium bicarbonate has CO3 minus, okay, full of ore ion minus plus 2. If you cross, you will get calcium HCO3 twice, calcium bicarbonate, right? Okay, so like that, okay, take the cation, its valency, anion, okay, valency. So cross these valencies and you can write the chemical formula, okay, easily. So practice this for some more. So then you have ammonium sulfate. I'll write here, okay, ammonium NH4. So for this plus 1, then sulfate SO4 minus 2. If you cross, you get ammonium sulfate. NH4 twice SO4, which is ammonium sulfate. So this is how, okay, here for the whole ammonium twice and SO4, okay, ammonium sulfate. So likewise, you can try writing chemical formulae for different compounds. Okay. So next you must know how to write the molecular mass of the molecule. Okay. We have learned the atomic mass, the relative atomic mass only we write, or given the unit A, mu and U. Okay. How to write the molecular mass? It's simply by adding the atomic masses. It is as simple as that. Okay. If you add atomic masses, you will get molecular mass. I'll give you some examples. Okay, the example number 1 is H2O. Okay, H2O for one hydrogen, which is plus 1, so 2 into 1. Okay, plus for oxygen it is 1 into 16. So 2 plus 16, so which is 18. Okay, if you want to calculate for HNO3, okay, HNO3, okay, there are 3 different atoms. So hydrogen 1 into 1, nitrogen 1 into 14. Okay, plus 3 into, for oxygen is 16. So which is 1 plus 14 plus 48, which will be equal to 63U. Okay, right? Atomic mass unit or unified atomic mass. Right? Okay, maybe I can write for calcium carbonate CaCO3. For calcium it is 40, 1 into 40. Okay, plus for carbon it is 12 into 1, 1 into 12 or okay, so plus 3 into 16. So which is, so 40 plus 12 plus 48. Okay, so for calcium carbonate is around 100. Okay, we calculate for MgOH twice. Okay, so for Mg it is 24, 1 into 24. Okay, so plus 2 oxygen atoms are there, 2 into 16 plus 2 hydrogen, 2 into 1. So it will be 24 plus 32 plus 2, 34, 38, okay, 58, which is the molecular mass. It is simple U, unified atomic mass or AMU. Okay, right. So these are the molecular masses of the different molecules. Right. Okay. So what is formula unit mass? Okay, which is exactly same as molecular mass only. The formula unit mass is written for ionic substances. That's the only difference. Otherwise, formula unit mass is same as molecular mass. The same way only you calculate. Okay, so the formula unit mass is done for ionic substances. You are given two examples here. So first example is NaCl, okay, which is ionic substance. So 23 for sodium plus 1 chlorine is 35.5. If you add, you will get 58.5. For calcium chloride, okay, for calcium chloride, calcium which is 40, okay, 1 into 40 plus 2 chlorine, 2 into 35.5, okay. So if you add 40 plus, which will be 71, which is 111 U, okay, for calcium chloride. So the same type of calculation only for formula unit mass, but the only difference is formula unit mass is for ionic substances, molecular mass is for all kinds of substances. So this is about molecular mass and formula unit mass. So we will calculate the formula unit, the molecular mass for two more substances as examples. Say for example, if we take C2H6, then 2 into 12 plus 6 into 1. Okay. So it will be 24 plus 6, which is 30 unified atomic mass. Okay. If you want to say calculate for say C2H5 OH, okay, which is ethanol. So 2 into 12 for carbon it is 12. Okay, 1 oxygen is there, 1 into 16. Okay, plus 6 hydrogen, 6 into 1. So it will be 24 plus 16 plus 6. Okay, which is 40, 46 U. Right? So like that, one more example, say K2CO3. Okay, for 1 potassium 39. So 2 into 39 plus carbon 1 into 12 plus 3 into 16. Okay, so it is 78 plus 12 plus 48, which will be, okay, 90, 138 U. Okay, like that you can easily calculate for molecular mass for different substances. So these values will get used to this for carbon 12, for oxygen 16, okay, then for potassium 39, like that you will get used to that. So when you keep calculating different molecular masses. So now we will check your understanding, right? Okay, this is some simple questions we will discuss. Which Dalton's atomic theory possesses the result of law of conservation of mass? Okay, okay. So the atoms will only present in different combinations in a particular reactions. Okay, we can neither create an atom or completely destroy an atom, right? Okay. So what is the ratio by mass of magnesium to sulfur in magnesium sulfide? Very important. Okay. So the formula is MgS. The formula is MgS. Okay. For magnesium it is 24. Okay, is 2. For sulfur it is 32. Right. So now the ratio is, right, so 32. Therefore 3 8s are 24 and 4 8s are 32. Magnesium sulfide. For magnesium 2 plus. For sulfide 2 minus. So it is simply MgS. You will get Mg2S2. If both are equal, then you can write simply as MgS. How many atoms are present in PO4 3 minus ion? Okay, you can easily find out. 1 phosphorus plus 4 oxygen. So there are 5 different atoms in PO4 3 minus ion. So write the formula for calcium hydroxide. Write the formula for calcium hydroxide. Okay. So hydroxide ion is OH minus. You will remember that. Okay. So you will get used to that. Right. So calcium hydroxide. So calcium 2 plus hydroxide is OH minus 1. Cross multiply, get CaOH twice, which is calcium hydroxide. What is the formula for ammonium sulfate? Okay. So ammonium is NH4. Okay. Plus 1 and sulfate SO4 2 minus. So cross this, you will get NH4 twice SO4. Okay, ammonium sulfate. Molar mass of SNO3, you have just calculated this, right? So it is 1 plus, okay, for nitrogen 14, for 3 into 16 for oxygen. So it is 1 plus 14 plus 48, which will be, okay, 63 U, right? What is the name of the compound aluminium? NO3 thrice. Okay, you know NO3 is nitrate, which is aluminium, which is simply called aluminium nitrate, which is not aluminium trinitrate, which is simply aluminium nitrate only. Okay, so here for aluminium, okay, plus 3 and NO3, minus 1, if you cross you will get AlNO3 thrice, which is simply aluminum nitrate. Okay, the 3 comes because of the valency, right? Okay, we have to see the valency. So because of valency only, we get AlNO3 thrice. Okay. So I hope you have understood about molecules and how to write the formulae for different molecules, how to find out the molecular mass. Okay, what are valencies? Okay, mainly we have seen ionic substances where there's a cation and anion, monoatomic, polyatomic cations and anions, and their charges, valencies, and how to balance their valencies. We write the chemical formula of molecules which is supposed to be neutral. Okay, therefore we have to balance the charges, positive negative charges. Okay, I hope you understood this topic very clearly. Okay, watch this space for more videos in chemistry. Okay, so next we will try to discuss the suction of an atom in the next video. Okay, thank you.